Okay, so this lesson is going to be topic 3.2, implicit differentiation. And we'll get through about half of this today, and then we'll finish up the note sheet on the next day we have class. So there's two types of forms of function. There's implicit form and there's explicit form. So implicit form is when the x's and the y's are on the same side. So these two are examples of implicit form. Right. And then explicit form is what we've been working with up until today, and that's when the functions variables are separated. So it's like solve for y. So if I took that first one that I wrote there, x, y equals 1, and solved it for y, explicit form would be y equals x over 1 over x. And we know how to find the derivative of that. You rewrite it as x to the negative 1 and you use the power rule. But if we try to do that for the second function, we can't. There's no way we can solve that for y. So we have to have a process for differentiating a function that's in implicit form that we cannot write another way. And that process we already have, and it's the chain rule. Okay, so this first example is just kind of get you in the thought process. So all of these we are going to differentiate with respect to x. So this first one, we're doing d over dx of x to the fifth. So we're going to do the power rule. And because the variables agree, that's all we have to do. We're done. All right, so this next one is a little different. We're differentiating with respect to x. So we're still going to use the power rule. But because the variables disagree, we have to multiply by the derivative of y. So that's like when we were using the chain rule before. If what's being raised to the power isn't just x, you have to multiply by the derivative of that. So we would multiply it by the derivative of y, which is going to be dy over dx. All right, so that's the basic idea of the beginning idea of implicit differentiation. So when we look at C, we're going to differentiate 2x squared by using the power rule. And the variables agree, it's just x that's being squared, so we're good. All right, for the 5y to the third, we're going to use the power rule. But because that variable is not x, we have to multiply by the derivative of y, which is dy dx. All right, and then D takes it a little bit further. It's a little more challenging because we're going to have to do the product rule. Okay, so we're going to leave x alone and multiply by the derivative of y. So we're y squared, sorry. So that's going to be 2y. And then because the variable wasn't just x that was being raised to the second power, we have to multiply by dy dx using the chain rule. All right, then we'll leave y squared alone and multiply by the derivative of x. All right, and then there's a little cleaning up we could do. No, that shouldn't be equals, it should be plus, sorry. Okay, so all of those ones where we have dy dx aren't quite finished, but that's how we get started. So for our guidelines for implicit differentiation, first, we're going to differentiate both sides with respect to x. When differentiating the variable y, we're going to multiply by dy dx. So let's just do that first. For example, 2a. All right, so we're going to start with finding the derivative of x squared. So that's going to be 2x. All right, and then minus, find the derivative of 2y cubed with respect to x. We are going to do the power rule. But since our variable is y, we're going to multiply it by dy dx. Right? And then for 4y, we're going to, that derivative is going to be 4, and then the derivative of y is dy dx. Right? What's the derivative of 2? That is just 0. The derivative of a constant is 0. All right, so that's step 1, which is kind of what we did in example 1. All right, step 2, collect all terms involving dy over dx on the left side of the equation and move all other terms to the right side. So let's do that. So we're going to leave anything that has a dy dx on the left, and anything that doesn't, we're going to move it to the right. So that 2x needs to move on over. Okay. Then step 3, factor out dy over dx on the left side of the equation, because everything over there should have a dy dx, so we're going to factor it out. Right? And then step 4, solve for dy dx. So the only way to solve for this is to divide by what it's being multiplied by. All right. Now, if this was a free response question, you could stop right there. Multiple choice, I don't think they would leave it in this form. What they would do, or what they would want you to do, is to factor out a -2 from the denominator and then cancel out a -2. So definitely the multiple choice answer would be written as x over 3y squared minus 2. All right, so that's implicit differentiation. Okay, so let's look at B. B's going to have some challenges because it looks like we're going to have to do the product rule twice. So this is a product and they involve variables, so we're going to have to do the product rule on this. And same thing here. It's a product that involves variables. We're going to do the product rule here. All right, so I'm going to do that one in green, and I'll do this one in blue. So let's start with the green. So we're going to leave x cubed alone, multiply by the derivative of y, plus leave y alone, multiply by the derivative of x cubed. Okay. And then we'll look at the next one. So we're going to leave 2x alone, multiply by the derivative of y cubed with respect to x. So that means we're still going to do power rule, but since the variable is y, we're going to multiply by dy dx. All right. Then we'll leave y cubed alone, multiply by the derivative of 2x, which is just 2. And then that equals the derivative of 14 is 0. Okay, so we'll clean this up a little bit. I usually, when I have a product involving x and y, I usually just go ahead and write it in alphabetical order, the x first and then the y. Oh, let me fix that real quick. I did the power rule wrong. You guys probably caught that. So you multiply by 3. Okay. So now we're ready for the second step, where we are going to move anything that doesn't have a dy dx to the right and leave everything on the left that does. And then we'll factor out the dy dx. And then we'll solve for dy over dx by dividing by what it's being multiplied by. Alright, so finally, dy over dx equals that fraction. Now we could factor out a common factor in the numerator, which would be y, and the denominator would be x, but then nothing would cancel. So I'm cool with you guys leaving it like that. Okay, let's do some more that involve some of the trig functions. All right, so we are going to do the product rule on this one. So we have 2 sine of x multiplied by cosine of y. So we are going to do the product rule. So we'll leave 2 sine of x alone, multiplied by the cosine of y. So that's going to be negative sine of y. But then because the variable is y, instead of x, we're going to multiply by dy over x. Then plus, we'll leave the cosine alone and multiply by the derivative of the sine. I said that wrong. Multiply by the derivative of 2 sine of x. And that equals the derivative of 3, which is 0. Okay, so we'll clean this up a little bit. All right, and we'll move over the term that doesn't have dy over dx. Sorry. All right, and let me fix that. I'm sorry. Okay. I don't have to factor it out because there's no addition or subtraction. Like these other ones, there were 2 terms added together or subtracted. They were both added that had the dy dx, so I needed to factor it out. Here, I don't. It's just one factor, so I'm going to divide by what's in front of my dy dx. So the negative 2's divide away to 1. And then if you guys notice, this is something. We have cosine of x over sine of x. What is that? That is cotangent of x. And then we also have cosine of y over sine of y. That is cotangent of y. So that's how I would want you guys to write your answers. You might have to pull out some trig identities out of your brain. That's when most of you remember the ratio identities. All right, we're going to do one more on this lesson. we're going to do D. All right, so we have tangent of x, it's just regular old term, nothing fancy there. But we have, oh, this one's not fancy either. I was thinking we were going to have to do the product rule. We're not. Okay, so the derivative of tangent of x is secant squared of x. Okay, then we want to find the derivative of 3 cotangent of 3y. I guess it is a little fancy. So that's going to be 3. And then the derivative of cotangent of something is the negative cosecant squared of that something. But then we have to multiply by the derivative of whatever that something is. So the derivative of 3y with respect to x is 3 dy over dx, since the variable was an x. All right, and the derivative of 1 is 0. Okay, so let's clean it up and move things around. Oh wait, we can multiply those 3's together and get 9. Okay. And we'll move the term over that doesn't have dy dx. All right, and then we'll divide to solve for dy over dx. Okay, so that is a perfectly fine answer. I did write down another possibility. We could rewrite it without the denominator and have it -1/9. And we do have the secant squared of x. But if I wanted to bump the cosecant squared up to the numerator, you would change it to its reciprocal, which would be sine squared of 3y. Okay, so don't be surprised on a multiple choice question that they would have that bumped up to the numerator. All right, so I'm going to have you guys for your Friday assignment to do page 145, 2 through 4, 6, 9, 10, 11, and 15.